Hey friends, I'm Shaptarshi. I just completed my Masters in Chemistry from IIT Kanpur. And in this video series for IIT-JAM exam, I wanted to cover all the different types of numerical problems that come for physical chemistry. And by doing those problems, I'll be explaining the concepts as well. In physical chemistry IIT-JAM, 90% of your questions will be numerical based. So it's very important. And just like this video, I'll be making similar videos on different physical chemistry topics as well. So with that, let's get started with this one.
Video, we will see the most important topics in this chapter of adsorption, which have a very high probability of coming in the exam. I've already written it down so that I'm not wasting time by writing the things down for you, right? So the most important things are your Frenlich adsorption isotherm, your Langmuir adsorption isotherm, and your Gibbs adsorption isotherm. Okay, and we will look into these topics. And I'll just give you like what is adsorbate and what is adsorbent. You guys know already that adsorbate is the one that is like being adsorbed, and adsorbent is the one like on which the substance on which it is being adsorbed, right? So I'm not getting into so much of small things because those are like you just know it won't come in the exam. Okay, this is important. This part is that some of the factors which adsorption depends. So adsorption, first of all, you should know that it is a spontaneous process. That means del G is negative. Also, the entropy, the change in entropy is negative because when adsorption happens, there is more of ordering and the translation modes of motion decreases. That's why del S is negative. And you guys know this formula of del G is equal to del H minus T del S. So if del G is negative, del S is negative. So this whole thing becomes positive. So to make del G negative, del H has to be negative. And if del H is negative, that means what? That is an exothermic process. If it is an exothermic process, what does that mean? Is that if we increase the temperature, the adsorption will decrease according to Le-Chatelier's principle. So or vice versa, I have written over here that if we decrease the temperature, the adsorption will increase. And also for pressure, as pressure increases, the adsorption increases. And this is shown by both your Frenlich and Langmuir adsorption isotherms. So what is an adsorption isotherm? Just a very quick intro. It's a analysis of the adsorption, variation of adsorption with pressure given that the temperature is constant, and that's why it's called isotherm, right? And now we'll come to this Frenlich adsorption isotherm, and this is the main formula that Frenlich proposed. It is an empirical in nature. There is not much of theoretical background in it, right? So when you know the formula, you can't just memorize the formula and go into the exam, right? You have to know what is the concept behind this, right? So what is the concept over here is that X gram of gas is adsorbed by M gram of adsorbent. That's why I explained what is this adsorbate and adsorbent. So a gas is being adsorbed on a solid, suppose, and normally this is what is seen, like gas being adsorbed on solid. This solid gas interface is mainly studied, at least in your level of BSc and IIT-JAM, right? So when something is being adsorbed, so that is X, right? So you should know what is X, that the amount that is being adsorbed, and M is amount, like the gram of the adsorbent on which it is being adsorbed, right? And I hope you guys know the difference between adsorption and absorption. Adsorption is mainly about the thing we study is about deposition of a molecule on a certain substance. But absorption, when we talk about, it's about that molecule being penetrated into that substance. So that's different, right? Over here, K and N are constants, and the P is your pressure. Simple, nothing much, right? We'll come to the graphs later, all in one, right? Now let us look at this Langmuir adsorption, and we'll come to the numericals also in the next video, okay? Because one video will be too long and for you guys. So Langmuir proposed this formula of theta equals to Kp is equals to 1 plus Kp. One of his main assumptions was that during this, the rate of adsorption is equals to the rate of desorption. And using this assumption, he deduced this formula, right? And over here we will look at what are the terms that over here. And so P is over here the pressure, K is the adsorption coefficient, and K can be expanded and written as Ka by Kd, where Ka is your rate constant for adsorption and Kd is your rate constant for desorption. Why the rate constant thing is coming up? Because that is how you deduce. That's what I said, that the rate of adsorption is equals to the rate of desorption, and that is how we deduced. And in the end he took K as K is equals to KT. So like you don't need to know the exact derivations before the exam. That's why I'm not going to details, because if you try to study everything right like the last moment, I mean I don't know how you can study so many things in the last moment, because syllabus is huge, organic, inorganic, physical, right? So, and over here, what is our theta? Theta is the fraction of surface area of adsorbent covered by adsorbate. So it is a fraction similar to x by m, but it's not x by m, right? It is a fraction of the surface area of adsorbent covered by, so the adsorbate is going on the adsorbent, and the fraction that of the surface area that it is covering. Simple as that. Okay. So sometimes all these things are written in the textbooks. Now some people try to memorize all these things. Try to imagine what is happening. When you imagine once, now what happens is that you will remember it for a long time. So theta can also be written as V by Vm. So sometimes in the numericals they will give you this different different parameters. So it should know what are the other forms of this Langmuir equation. What are the other forms of French, right? So theta is equal to V by Vm. V is your volume of gas adsorbed, and Vm is the maximum volume of gas adsorbed for monolayer. So for monolayer it means that the whole layer of this adsorbent is totally filled up by the adsorbate. So that is the best possible scenario. But normally that doesn't happen, right? So normally maybe something less than that whole surface area is covered. So that is the volume of gas adsorbed, and in the best possible scenario, it is the maximum volume of gas adsorbed for monolayer. We'll look at a numerical about this in the next video also, right? And now we come to our this another form. Now we talked about this x by m, right, in our French, where x was our mass of gas that is adsorbed and m is the mass of the adsorbent, right? So that can be related to theta by proportionality constant called k1, right? And we know that formula of theta is what? The formula of theta is kp by 1 plus kp. So if we just replace it, x by m is equal to this, and this form, there are some graphs about this form which you should know, and this is of this your y is equal to mx plus c form. So how did we get from here to here? It is simple maths, nothing as such. You put p as a subject over in the top, and you inverse this x by m, and you consequently change your right hand side as well, and you will get this form. It's nothing, it's class 10 level. This is okay. So sometimes we make mistakes, it happens. Okay, so now we'll look at the graphs, okay, because this is also a bit important. So in French propose this x by x is equal to kp 1 by n, and this is the graph that we get. And how do we get this graph? So initially, so this n, so when we are actually seeing this graph, what has happening is in the initial part, x by m is proportional to p. So you can see it's a straight line. Initially it's like a straight line, right? So as it is varying with pressure, initially it's like a first order with p, and then what happens is as it is going forth, this is like more of the intermediate states when it's p1 by n, and then it becomes a flat. Flat means what? That it is it is not anymore proportional to p, or doesn't depend on p, we can say like that, right? So this was a more detailed of this graph. Some more of the times in this BSc level this detailed is not asked, but I just said because it is too easy, because a very similar thing you will get to see in this Langmuir only. So it is very too easy, that's why I thought I can just mention. I don't want to pressurize you guys too much. Another form which is very important is this log is equal to xm. So we just take the logarithmic of this whole formula and we get this log xm 1 by n log p plus log k, right? And what we see over here is it's a y is equal to mx plus c form, and so this is our y, this is our x, this is our m, and this is our c. So you should know this. Sometimes they will just simply give you like this, like k has this value, p has this value, find this. You have to just put the formula and find it, nothing big. Okay, it's quite easy. But if you don't know the form, then how will you do it, right? Or if you don't know this exists in the heat of the exam when you are already so scared. So if you know it, it's good. Now we come to Langmuir, and this I believe you guys have already studied this famous, all these three cases when P is low, when P is high, when there's intermediate pressure. So when P is low, we can say that 1 plus Kp is almost equal to 1 because pressure is low. So we can say that theta is equals to Kp by 1. This denominator becomes 1. So it's K p to the power 1, which is a first order. And this we can see when it is like a straight line. So when it is a straight line, we can say it's like a first order, right? So this part is 1. When pressure is too high, so 1 plus Kp is like Kp, and the denominator becomes Kp and the whole becomes 1. 1 into P to the power 0. So I'm just saying that is 0 order. So 1 into P to the power 0 is actually 1 order, right? So this end flat line that comes in is because of this pressure is high, right? And when it is intermediate pressure, it is an intermediate region. We can say like this formula of theta equals to Kp 1 by n.
That there are some special cases for Langmuir when we said about this x by m equals to k1 theta, and this formula that we have arrived at, right? It's very easy to arrive at this, and this is y equals to mx plus c form. And so there is a graph for this that I had told that I will show you guys, and the graph is over here. So this is the graph of p x by m into p, and over here this is our y, this is our x, our m is 1 by k1 and our c is 1 by k1k. So this is actually, I won't say very important, but this has been stated actually in the like BAc syllabus at least, so I thought of just telling you about it, right? So now we come to Gibbs adsorption isotherm. This is quite important, right? And I have some numericals also on Gibbs absorption isotherm on the next video, which you should see at least to get some idea of how to apply those concepts that you're having right now. So first of all, what is this Gibbs absorption isotherm? Many people skip this topic. Please don't do it. It's a bit important. So it represents the relationship between your adsorption and the change that happens in the surface tension of the solvent as a solute is added. I will repeat it one more time. It represents the relationship between the adsorption and the change that happens in the surface tension of the solvent as we add the solute, right? So, and I'll just tell you, this is a formula, and these are the terms. C is the concentration of solute, gamma is our surface tension, which we are seeing the change of surface tension of the solvent as the solute is added, right? So that was the definition also. And over here we also have the excess concentration of solute on surface per unit area. Okay, and we have some numericals on this which will clarify your concepts much more in the next video, because that's also very important. And something that is very important is some cases over here. So I'll just show you the formula over here. So this was the formula, and just note it down or take a screenshot as you wish. And some cases are very important. If the solute that we are adding, okay, if the solute we are adding, if it lowers the surface tension, then our excess concentration of solute on surface per unit area, this term will have a positive sign, or this will be a positive term. Why is this? Because if the surface tension is lowered, then our adsorbed bed will try to stay on the surface, because of which the surface excess, this is the surface excess also called, the surface excess will have a positive term. But if the solute, it raises the surface tension, what happens is that our adsorbate can go to the bulk, right? And if it goes to the bulk, our surface excess will decrease or will have a negative value. So these cases are, guys, very important, and it can come in the exam. Something that is not that important, but I just wanted to tell you because I really want you guys to get very good marks, right? That's why I'm doing these videos. So physisorption and chemisorption difference, I know you guys have studied. These are the most important differences, guys, that in physisorption the reaction is reversible, in chemisorption it's irreversible. In physisorption it's obviously by weak van der Waals, weak forces. In chemisorption it's strong valence bond forces, strong forces. In physisorption it's multi-layer, but in chemisorption it's monolayer. These are the main differences. And so with that, the concepts are over, guys. I'll do the numericals in the next video. That's quite important. I'm not telling that my videos are the best or something, but if you do all these numericals, you can actually apply those concepts, and you will, if you have the idea of the concept and now you're applying the concepts, now you have both these cases, right? So then that's the best combination you can have, and you will be prepared for the exam. Okay, guys, God bless.